Hello and welcome to Chemistry Talk. I'm Hunter, and today what we'll be doing is writing molecular and ionic equations. So by now you should be able to write and balance a molecular equation from given a word equation or given the full reaction itself. So first thing to do is to write the molecular equation. So a solution of lead 2 nitrate, okay. So I'm just going to automatically write the compounds here. But if you need practice with that, check my ionic compounds video. And sodium iodide react to give us, oh, whoops, need a pencil there, need a arrow there. React to give us lead iodide and sodium nitrate. So after you check that the equation is written correctly, which I'm going to check after I can just fit that properly, your next thing to check is that it's balanced. So 1 lead on this side, check. All right, I already see something that's off balance here. We have 2 nitrate on this side, but only 1 on this side. So the only way I can think to balance that is to put a 2 in front of that one and a 2 in front of that one to balance the iodide. So now the sodium's balanced, the nitrate's balanced, and the iodide's balanced. Okay, so let's rewrite this full equation here nicely so we have something to work with. Give us lots of room here. So we have lead 2 nitrate plus sodium iodide, and we get lead iodide and sodium nitrate. Okay, so that is the balanced molecular equation. Now we're on to part 2, and part 2 asks for the total ionic equation. So how we're going to do this is we need to identify the solubility of the compounds that we were given, meaning you need to look at your solubility table if you don't have it memorized or if you don't need to memorize it. So we know that these 2 solutions are aqueous because it's a solution. So we're mainly concerned about the products. Now, lead iodide is a solid per the solubility table, and sodium nitrate is aqueous, so it's going to break apart into ions. Solids don't break apart into ions. They stay together. So here we're basically going to write the equation, but ionically. So we have the ions separated. So we have, starting from the left, lead plus 2 ions. We have 2 nitrate minus 1 ions. We have 2 sodium plus ions. We have 2 iodide minus ions, but we don't touch the solid. It stays together. We have 2 Na plus ions and 2 NO3 minus ions. So notice how the aqueous substances come apart into ions, but the solids stay together. So that is the total ionic equation. We've separated everything into ions that can be separated. And notice that the amount is congruent. So 2 nitrate, 2 sodium, 2 iodine, 2 sodium, and 2 nitrate. Now the next thing to identify before writing the net ionic, is to identify any spectator ions. Now what a spectator ion is it's an ion that is the same on both sides, so consequently cancels out, and it's basically a spectator to the reaction. It's just watching it happen. It's not really contributing anything important because it cancels out on both sides. So we have a couple of those here. The compound, the solid compound, contains the elements that will never be spectators because they're not the same on both sides, because you have a solid and you have ions on the other side. So that will always be the spectators. But here we can use a different color. We can cancel out the nitrates and the sodium, and we can cancel out them on both sides because they're the same. So our net ionic equation is just going to deal with lead and iodine. So our net ionic equation is lead plus 2 and 2 iodine minus to give us lead 2 iodide. And that is the net ionic equation, meaning it's net. It's the gross amount net ionic, meaning things that could cancel out have canceled out. That's the total ionic right here. This includes spectator ions, and this is the molecular equation. So I hope this helps understanding the total ionic versus net ionic versus molecular. If you have any questions, leave them in the comments below. If you have any requests, leave them in the comments below. Thanks for watching.